In this video, I'm going to explain how to solve linear and quadratic inequalities in one variable algebraically. In later videos, I'm going to show you how to solve these inequalities graphically. Let us start with linear inequalities. So a linear inequality in one variable is an expression that can be written in one of the following forms. Either ax plus b is greater or equal to c, greater, less or equal to c, or less than c. And as I explained in the video of linear equations, an expression is linear if the highest exponent of the variable is 1. So as you can see in these representations, there is no exponent of x higher than 1. Let us now do some examples. So if we have something like that, we simply expand the expression, then we group all the x's on one side and all the numbers on the other side, exactly as we do in linear equations. So this becomes 2x minus 3x plus 12 is greater or equal to 4 minus 2x plus 14. 2x minus 3x is greater or equal to negative 2x, and 4 plus 14 is 18. Now we group all the x's on one side and all the numbers on the other side. So minus x plus 2x is greater or equal to negative 12 plus 18. And finally, we get x is greater or equal to 6. Now this is not everything. We have to represent the solution as an interval. In order to do that, we first represent the solution on the real number line. Let's say 6 is here. We have greater or equal. Since we have an equal sign, we add a full circle at 6. Now since x is greater than 6, this means x could be any value greater or equal to 6. So we draw an arrow to the right. Now some students might get confused here with the direction of the arrow. There is a little trick which might help them. So if you have a greater sign, as our example here, we can draw a little dash, and as you can see, we get an arrow pointing to the right. Similarly, if you have less than sign, and you add a little dash like that, you will end up with an arrow pointing to the left. So using this trick, you will never get confused with the direction of the arrow. Finally, we have to write the solution as an interval, so x takes all values starting 6 up to positive infinity. This means that x belongs to the interval closed at 6 and of course open at positive infinity. For this example, it is always easier to get rid of the denominator. How do we do that? Multiply the entire expression by a number which is divisible by all the denominators we have. In this case, we only have 2. The other denominators are 1. This means we can multiply by 2. So the expression becomes 2 times 3x minus 1 over 2 is greater than 2 times 3 into x minus 1. Of course, we have to multiply 2 by every single term in the inequality. So 2 is cancelled with 2, and we get 3x minus 1 is greater than 6x minus 6, because 2 times 3 is 6, and then we distribute, and we have plus 8. And negative 3x is greater than 3. Now there is a very important note here. It's that when we divide by a negative number, we must flip the sign. So this becomes x is less than negative 1. But why do we have to flip the sign? Well, let's say for example we have 2 is less than 5. Of course 2 is less than 5. If we multiply both sides by minus, we get negative 2 and negative 5. But of course, we cannot keep the sign as is because negative 2 is not less than negative 5. Negative 2 is greater than negative 5. So that is why whenever you multiply by minus, we must flip the sign. What is left? We have to represent the solution on the real number line, then write the solution interval. Now x is less than negative 1, so there is no equal sign, which means I have to add an empty circle at negative 1. And x is less than negative 1, which means if we add a dash, it looks like an arrow pointing to the left. So that is the solution region, and therefore x belongs to the open interval negative infinity minus 1. Now what if we have a two-sided inequality? Our task here is to end up isolating the x in the middle. which means we have to get rid of the 1 over 3 as well as the 2. Let us start with 1 over 3. To get rid of 1 over 3, we multiply the entire inequality by the reciprocal of 1 over 3, which is 3 over 1, or simply 3. So we get 3 times 1 is 3, 3 times 2 is 6, 3 times 1/3 is cancelled, so we have an x that is less or equal to 6. Next, we have to get rid of the 6. How do we do that? We minus 6 from all the sides of the inequality. So we obtain 3 minus 6 is -3, less than x less or equal to 0. And finally, we got x isolated in the middle. So now we move on to the number line. There is no equal sign at -3, which means we have to add an empty circle, but we do have an equal sign at 0. Then we join both circles and we obtain the solution region. Therefore, x belongs to the interval -3 open, 0 closed. We now move on to the quadratic inequalities in one variable. So a quadratic inequality in one variable is an expression that can be written in one of the following forms. So we have a second degree trinomial, and the sign could be either greater or equal, or greater, or less or equal, or less. Now to solve a quadratic inequality algebraically, we have to apply the following recipe. We must make sure that one side of this inequality is 0. This is very important. Next, we either factor the quadratic expression or we use the quadratic formula in order to find the zeros of the trinomial. After that, we label the zeros we got on the real number line. Then we use the so-called test values to find the sign of the quadratic expression on each interval. And finally, we find the solution interval. Let us apply this recipe on some examples. All right. According to the recipe, we must make sure that one of the sides of this inequality is 0, and yes, it is. We move on to the second step. So either we factor or we use the quadratic formula, but here it is easy to factor. So this becomes x minus 2 multiplied by x minus 3 is less or equal to 0. And I explained how to factor trinomials in details in a previous video. Then we find the zeros for each factor. So if we have x minus 2 is equal to 0, this gives us x is equal to 2. And if x minus 3 is equal to 0, we get x equal to 3. Now we label the zeros on the real number line. Now we have 3 regions. That is the first region, that's the second, and this is the third. Now we have to choose test values on each interval. What is meant by that? For example, in this region, which starts at -infinity up to 2, we pick any number between -infinity and 2. Let us take 0. Again, you can pick any number, not necessarily 0. Whatever the number you pick, you're going to get the same result. Between 2 and 3, let us pick 2.5. And between 3 and +infinity, let us pick 5. Now for each one of the numbers that we picked, we plug it in into the main trinomial and check the sign. So if I replace 0 by x squared minus 5x plus 6, I will obtain 0 squared minus 5 times 0 plus 6, and that is equal to 6, which is positive. So this means in this region we add a plus sign. So x squared minus 5 plus 6 is positive for any x value you choose in this region. Similarly, if I replace x by 2.5 in this expression, I will get 2.5 squared minus 5 times 2.5 plus 6, and the answer is -0.25. So that trinomial is negative in this region. Now we do the same thing for 5. So we have 5 squared minus 5 times 5 plus 6, and that is a 6. So the trinomial is positive here. Now we arrive at the final step of the recipe where we have to choose the solution interval. So the inequality is x squared minus 5x plus 6 is less or equal to 0, which means we have to choose the negative sign. Therefore, x belongs to to the interval 2, 3. Why 2, 3? Because this region starts at 2 and ends at 3. And since we have an equal sign, this means both 2 and 3 are included. So we add rectangular brackets, and that's the solution interval. For number 2, let's repeat the same process. So there is no zero side, which means we have to move the -4 to the left. This trinomial is not easy to factor. Let us use the quadratic formula. So x is equal minus b plus or minus the square root of b squared minus 4ac over 2a, where a is minus 3, b is -5, and c is minus 4. So we plug in all the values in the expression and we get the following answer. And these numbers are -2.25 and 0.59. Let us now label these numbers on the real number line. We now choose the test values. So let's pick -5 here, 0 here, and let's say 2 here. We plug in these values into this trinomial and we obtain the following signs: minus, plus, and minus. We have a less sign, which means we have to choose the negative regions. That's the first region and that's the second. Therefore, x belongs, and here we have no equal sign, which means we have to use open intervals. So minus infinity, -2.25. That's for the first region. For the second region, we have 0.59 and plus infinity. So here, x could be either here or here. What did I just say? I said or, so that means a union. And this is the solution for this inequality. For number 3, that is a perfect square. So it is x minus 3 to the power of 2 is greater than 0. So the only 0 we have is x equal to 3. Let us draw the number line. So here we only have 2 regions. Let us choose 0 here, and let's say 5 here. We replace 0 by this trinomial, so we get 0 squared minus 6 times 0 plus 9. That is a positive answer, so you put a plus. Same for 5. If you plug it in here, you will also get a positive answer. And the solution region is this interval as well as this interval, but we have to exclude the 3. Why? Because there is no equal sign here. So the answer is x belongs to -infinity 3, open interval, union 3 plus infinity, open interval. Now, if we have an equal sign, this means the solution will be everything with 3 as well. So everything will be included in this case, which means x belongs to -infinity, positive infinity, or the set of all real numbers in this case. One last example. So we have x squared plus x plus 1 is less than 0. We cannot factor this trinomial, so we use the quadratic formula. And this is what we get. Since we have a negative number underneath the square root, this means there are no zeros for this trinomial. We now draw the number line. Since there are no zeros, we do not add any number on the real number line. What do we do instead? Well, we pick any number between -infinity and positive infinity, let's say 0. You plug it into this trinomial, and I will get positive. And no matter what the number I choose on the number line, I will always obtain a positive answer in this case. But we have a less sign for this inequality. This means that we have no solution. And that is all about how to solve a quadratic inequality algebraically.